Hi everyone, welcome to this workshop. Today we practice on solving absolute value equations and inequalities. So first of all, let's talk about solving an equation contain a single absolute value term. In this example, we have absolute value of x equal to 5. So let's talk about this problem. What is absolute value of x equal to 5 stand for? So to explain it easier, I need to rewrite this problem as x minus 0 will still give me x equal to 5. So question is, why do I need to rewrite this problem? So if I write this way, the problem will be read like this. We have what numbers is 5 units away from 0. So away from 0. Subtract is stand for away from 0. So what number is 5 units away from 0? To answer that problem, we need to construct the all real number line and then find out what number is 5 units away from 0. So we have 0, 1, 2, 3, 4, and 5, and 6, and I also have the negative side, so -1, -2, -3, -4, -5. I believe this is good enough. So here my 0 is 5 units away from 0, let's say on the right side, so 1, 2, 3, 4, 5. So positive 5 is 5 units away from 0. How about the left side? So let's count 1, 2, 3, 4, 5. So we have -5 is also 5 units away from 0. So we have x equal to -5 or x equal to 5. So let me bring this one, let's make the problem more clear here. Let's rewrite the whole thing. Absolute value of x equal to 5. We have the answer is x equal to positive 5 or x equal to -5. It comes straight from the graph. So we pick up the idea is when you drop the absolute value, you see the next step, I don't have the absolute value bar anymore. So when you drop the absolute value, we have two equations. The first one is it stay almost exactly the same without the absolute value bar. And the second equation, you have the negative on the right side. So let's pick up that idea and solve example 1. So let's say if I have example 1, if I have absolute value of 3x minus 2 equal to 5. Okay, so as the idea we learned before, the next step I'm gonna do is drop the absolute value. So when I drop the absolute value, we have two equations. The first one is 3x minus 2 equal to positive 5. The first equation stay exactly the same. The second equation, or 3x minus 2 equal to -5. So -5. So make sure this one we have to change the sign as negative. Then we go ahead and solve for each equation. So isolate the x, add 2 on both sides. So we will have 3x equal to positive 3, and 3x equal to 7, and we divide by 3 on both sides. So x equal to 7/3. X equal to 7/3 is my first solution. Now the next part, to isolate the x, we're going to do is add 2 on both sides. We will have 3x equal to -3 and divide by 3 on both sides. Then we have x equal to -1. Divide by 3 both sides, we have x equal to -1. So x equal to 7/3 and x equal to -1 is my answer for this problem, this absolute value. So we have some idea about solving absolute value equation. So let's go over two more examples so that we have a better understanding about solving an absolute value equation. So example 2, you have absolute value of 2/3 x plus 3 plus 4 equal to 10. So first of all, we need to know that when you're solving the absolute value, we want absolute value stay by itself on the left side without any number in front or behind the absolute value. So I have to do is, first of all, isolate the absolute value by move 4 over. Always have to set the absolute value by itself. So move 4 over, subtract 4 on both sides, you will have 2/3 x plus 3 and close the absolute value equal to 6. Now since absolute value stay by itself, now I can drop down the absolute value bar and break down a two equation. The first one stay exactly the same, 2/3 x plus 3 equal to 6, or 2/3 x plus 3 equal to -6. Always negative, and then the number on the right side, always negative on the right side. Then my next step is solve for x. So we have fraction, you know what to do. Fraction, so we multiply by LCD, which is 3. So multiply all three terms by 3. That will help me get rid of the denominator. Then we will have 2x plus 9 equal to 18, and we isolate the x, subtract 9 on both sides. We have 2x equal to 9 and divide by 2 on both sides. You will have we will have x equal to 9/2. Okay, that is my first solution for the positive equation. Now let's do with the negative equation. We have fraction again, so multiply all three by LCD is 3. Now we have the second equation, 2/3 x plus 3 equal to -6. So we have to do a fraction again. So multiply the whole equation by 3. So 3 here, and 3 here. We can reduce the 3. Give me 2x plus 9 equal to -18. Then isolate the x, subtract 9 on both sides. So we have 2x equal to -27. -27, yes. And divide both sides by 2. Then we have x equal to -27 over 2. And that is my second equation, the second solution for the negative equation. Okay, now in example 3, we have negative absolute value of x plus 1/2 plus 3 equal to 7. So again, we have to set the absolute value by itself. So I need to move all the sign, and the number is not necessary have to be on the right side. So we're gonna isolate the absolute value, subtract 3 on both sides. You will have negative x plus 1/2 equal to positive 4. And then we need to get rid of the negative in front of the absolute value. So I'm going to do is divide the whole equation by -1. Or you can also do is multiply the whole equation by -1. So negative over negative will give me positive. And on the left side, we have absolute value of x plus 1/2 equal to -4. Now there's a problem here. We know that absolute value stand for a distance. Then this one always give you a positive solution. It's because it's the distance. Right now it's equal to a negative number, so which does not make sense. So my answer will be no solution. No solution, because the conflicts right here, the conflicts right here. So keep in mind the absolute value always equal to a positive number. It cannot equal to a negative number. Subject part. Now it's your turn to tell me, did you understand the concept? So I have 4 problems for you to practice on. Just if you get stuck or you don't know how to solve, just go back to the example. Make sure you understand the concept. Good luck everyone. So you have 5 seconds to pause the video or you will see the answer right after 5 seconds. Okay, good luck. So I believe we already have the answer. So let's go over each problem and see did we get the correct answer. So problem 1, absolute value of 2x plus 3 equal to 5. So we learned that if I drop the absolute value, we have 2 equations. So the first equation will be 2x plus 3 equal to 5. Or second equation is 2x plus 3 equal to negative 5. So make sure negative on the right side of the second equation. So negative 5. Let me use the correct color. So negative 5. Now we will solve each equation. So isolate the x here by subtract 3 on both sides. You have 2x equal to 2. Then we divide both sides by 2. What's wrong with my pen here? Divide by 2 on both sides. So we will have x equal to 1 is the answer for the first solution. Now the second one, I'm going to subtract 3 on both sides. We will have 2x equal to negative 8. And we divide by 2 on both sides. You will have x equal to negative 4. Okay, let me fix this. So x equals to negative 4. X equals to 1 and x equals to negative 4 is my solution for problem 1. Now in problem 2, we have the negative absolute value of 3x plus 2 equals to 4. As we see that we have the negative in front of the absolute value, I need to get rid of this negative to be able to break down at 2 equations. So we're going to do is divide by negative 1 on both sides. The goal, we divide the negative 1 so that we can reduce this negative over negative will be positive. Leave me with absolute value of 3x plus 2 equal to negative 4. And the guy caused problem here, absolute value cannot equal to a negative number. So I don't need to solve this. The answer is no solution. Okay, now let's go over problem 3. So on problem 3, you have absolute value of 3 half x minus 3, close absolute value, plus 1 equal to 7. As we know that we need the absolute value stay by itself, so I need to subtract 1 on both sides, so that we have 3 half x minus 3 equals 6. Since the absolute value already by itself, then I'm going to do is break down at 2 equations. The first one is 3 half x minus 3 equal to 6. Second one is or 3 half x minus 3 equal to negative 6. This problem quite look familiar. We have those 6 before. Alright, so we need to get rid of fractions. So we know the LCD of this equation is 2, so multiply every terms by 2. 2 divided by 2 will be 2 divided by 2 is 1 time, and 1 times 3 is 3. So we have 3x. We have 3x minus 6 equal to 12. And solve for x, so add 6 on both sides. Then 3x equal to 18, and we divide by 3 on both sides. Divide by 3 on both sides. That give me x equal 18 divided by 3 give me x equal to 6. Okay, now we do the same on the right side. LCD is 2, multiply every single term by 2. So 2 go to 2 is 1 time, and 1 time 3 give me 3x. 3x minus 6 equal to negative 12. We add 6 on both sides to isolate the x. So 3x equal to negative 6, and divide by 3 on both sides. That will give me x equal to negative 2. Then my answer for this problem is x equal to 6 and x equal to negative 2. Okay, now last problem. We have an absolute value of 1/2 x minus 5 minus 4 equal to 4. So what we're going to do is add 4 on both sides so that absolute value will stay by itself. So absolute value of 1/2 x minus 5 equal to 0. Then my next step is split out at two equations. So 1/2 x minus 5 equal to 0, or 1/2 x minus 5 equal to, add the concept equal to negative 0. Oops, there's some problem here. We have positive 0 and we have negative 0, but the problem is 0 is the center of the number line. This cannot be positive or negative. 0 is 0, which means this negative 0 is also stand for 0. Basically, we just have one equation. We just have this one. We don't have the negative side because 0 is 0. So I'm gonna go back on the first step. So basically, we just have one equation because it's equal to 0. So we're gonna solve this one. We have fraction, multiply both sides all terms, both sides are all terms by 2, so that the 2 and 2 cancel out, leave me with 1x equal to negative 10, but 1x minus 10 equal to 0. Then let me bring it over here. So x minus 10 equal to 0. I need to isolate the x, so move 10 to the other side by add 10 on both sides. Then we will have x equal to 10. So my answer for this equation is x equal to 10. So it's a new idea here. If you have an absolute value equal to 0, which means we just have one solution. Alright, thanks everyone. Hope that we all have correct answer. Now let's do one more example before we move on to solve an inequality. So example 4, you have absolute value of 5x plus 3 equal to absolute value of 3x plus 25. So it's the same idea like we saw before. So my first step is break down the absolute value at two equations. So the first one stay exactly the same with the positive on the right side. So 5x plus 3 equal to positive on the right side. So it's still 3x plus 25. Now, or the second equation is 5x plus 3 equal to, so as we know we need a negative on the right side, but right now on the right side is a binomial, so I need a parenthesis for 3x plus 25. Then we will solve each equation individually. So on the left side, I'm gonna bring x to one side, so subtract 3x on both sides, which give me 2x plus 3 equal to 25. Then we move 3 over, subtract 3 on both sides. We have 2x equal to 22. Then divide both sides by 2. We will have the final answer for the first equation is x equal to 11. Now, on the right side, we have 5x plus 3 equal to negative times 3x plus 25. At the tip I gave you before, if you have problem to just do a negative side, we think that we have one invisible in front of the parenthesis, then we just need to do is distribute the negative one. Then you will have 5x plus 3 equal to negative 3x minus 25. So this parenthesis really important. If you don't have this parenthesis, you would think that we have negative 3x plus 25, which is wrong. So as you see, if we do correct way, the right way, you will see that we have the negative 3x minus 25. So let's finish this up. We solve for x, bring x to one side. Then we have ax plus 3 equal to negative 25. Then we move 3 over. We have ax equal to negative 28. And divide both sides by 8. Then we have x equals to 8 go to 28. 8 doesn't go to 28, but we can reduce by 4. If we reduce this one by 4, which will give me divide top and bottom by 4, that will give me negative 7 over 2. Oh, and that is the lowest term. Negative 7 over 2 is my answer for the second equation. And x equals to 11 is the answer for the first equation. So as we see, even we have two absolute values on both sides, we still solve the same way. Make sure you just need to remember that when you put the negative on the right side, we need the parenthesis. So that is really important. We should write a note down here. Maybe we need the parenthesis for the right side. Okay. If it's not clear for you, just use your own word. As long as you get the concept, the idea here. No, we go over the second section. Solve an inequality in one variable containing one absolute value term. So we have two problems need to think about. I don't know, do you still remember the absolute value of x equal to 5? So in this case, we'll break down at two cases. You have absolute value of x greater than 5 and absolute value of x less than 5. So let's go over each of them and see what's the difference between two problems and what's different with the equations. So like we did before, I need to rewrite this problem as x minus 0 greater than 5. X minus 0 is still giving me x, so basically I didn't change anything. I just rewrite the problem. So by rewrite this way, we will have the problem written as what number is 5 units greater than 0. So what number is 5 units greater than 0? To answer this problem, we need to draw the number line out and then find out what number is that. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8. So, and also on the negative side, negative 4, negative 5, negative 6, negative 7, and we have negative infinity, positive infinity. So let's count on this one. So here my 0 right here. So 1, 2, 3, 4, 5. Any number is 5 is the 5 units away from 0. So 6 is 6 units away from 0, which is greater than 5, and also 7 is 7 units away from 0. So any number greater than 5 will give me the distance greater than 5. So my answer will be go face that way, greater than 5 will be give any number greater than 5 will give you the distance greater than 5. Now let's say, how about on the left side? So we count 1, 2, 3, 4, 5. So negative 5 is is has 5 units away from 0. Negative 6 will give me 6 units away from 0. Negative 7 give me 7 units away from 0. So any number less than negative 5 will give me the distance greater than 5 units away from 0. So we will have the graph like this. So based on this graph, we can say that x, if x less than negative 5 is one of the solution, and on this side we will have x greater than 5 is another solution. So now let's bring them close to each other. We will have x greater than 5. The answer will be x greater than 5 or x less than negative 5. And I use the letter or to connect them because we have two solutions and they both is my solution, is our solution. So or stands for union. And as we observe that the first inequality is stay exactly like the original problem. And the second inequality we have to do is flip the inequality sign and change the sign of the number. So that's how we do with absolute value of x greater than 5. Now let's go over problem B. As we know that I have to rewrite the problem to explain this is better. So if you know the question which I'm gonna say, just go ahead speak along with me so that you will study better, you will understand the problem better. So what number is 5 units less than 0? Okay, and I believe I speak on the wrong time here. It should be what number is 5 units away less than to 0. So to answer this problem, we're gonna do is use the number line and then see what number is 5 units less than 0. So we have 0 here, again 1, 2, 3, 4, 5, 6, and also the negative sign. -2, -3, -4, -5, -6, -7. So we know that -5 and 5 give you 5 units away from 0, which means any number less than -5 will give you the distance less than 5 units away from 0. So any number between 5 and -5 will look like this. Will give you the distance less than 5 units away from 0. So we will have the answer look like this. We have -5 less than x less than 5, which means x between -5 and 5. So, but writing this way is not quite help me figure out the concept how to solve the problem. So I'm going to change it a little bit. So let's say I can think it's this way. I can think any number greater than -5 is one part of my solution, and any number less than 5 will give me another solution. Since the answer is the one in the middle, the one they overlap, so I will say that we have the following. We have x x greater than -5, and it stands for the overlap part, x less than 5. So writing problem in this way, that will help me figure out the concept, because if you bring the problem close to each other, let's say if I bring down the original problem, absolute value of x less than 5, then with this one I can put them in x less than 5 and x greater than negative 5. As we see that the first inequality stay exactly the same like original, and the second inequality we have to flip the sign and change the sign of the number. So we use the same concept for both or and and problem. But the problem is how can we figure out when we use or and when we use and and stand for overlap. So when we use which one? So I will talk more about both of them for the next example. So let's go over example 1. We have absolute value of 2x minus 3 minus 2 less than 7. So before we get into solve this problem, there's two notes we should write down. So as we know that OR is stand for take all possible solution. Take all possible solution. And we also know AND is stand for the overlap. So we're looking for the overlap part. Okay. All right, let's get in and solve the problem. After that, we will identify which problem to use or which one to use and. As we know that to solve the absolute value, we need the absolute value to stay by itself, which means this negative 2 is not supposed to stay here. We have to move him over by add 2 on both sides. That will give me 2x minus 3 less than 9. Now I can break down at two cases. So the first case stay exactly the same. We have 2x minus 3 less than 9. And the second case is 2x minus 3. We have to flip the inequality sign and change the sign of the number. So greater than negative 9. So the problem is, which letter should I use here? Should I use or should I use and? So here's the tip for you. So as we know that and or, let's say A stand for and O stand for or. In alphabet, we have A stand in front of O. So N first and then O. And then my next step is fill in the inequality between them. Let's say we have right now is less than 9. So I will bring this inequality, put it between A and O. So we have greater than, less than. So when you put it in, you will see that this inequality will point to me which one I should use. So I will use N as the connection between two inequality. So my problem is N problem. So my next step is solve the inequality on the right side by add 3 on both sides. We have 2x less than 12 and then divide by 2 on both sides. Then we have x less than 6. And on the right side we add 3 on both sides. That will give me 2x greater than negative 6. Then we divide both sides by 2. Then we will have x greater than negative 3. Now we're going to graph them out, put both of them in the number line. Negative infinity, positive infinity, mark 2 point. So this is my negative 3, this is my 6. Put the tail for the inequality at 6. That point may go to the left. So at 6 we're going to do is make the line go to the left. Without an equal sign, we use the parenthesis because which means not includes number 6. And put the tail for inequality at negative 3. Then we see that arrowhead point me to go to the right. So I will make the line go to the right without equal sign again. So that would be another parenthesis. So seeing this N, we're looking for the overlap. Based on this graph, we see that they overlap from negative 3 to 6. So my answer would be parenthesis negative 3 comma 6 and close parenthesis. And that is our answer for this problem. Okay, let's go over 2 more examples to make sure we understand the concept. So example 2, we have absolute value of 3 minus x over 5, close the absolute value, greater than or equal to 6. So in this problem, absolute value already by itself, so we just need to do is break them down at 2 inequality. So the first one stay exactly the same as always. We have, excuse me, so the first inequality stay exactly the same. We have 3 minus x over 5 greater than or equal to 6. And the second one is 3 minus x divided by 5. We have to flip the inequality sign and change the sign of the number. So less than or equal to negative 6. The question is, which letter should we connect this to inequality? So as we just learned the tip before, we have A stand for N and O stand for OR, and in alphabet A before O. Then my next step is put the inequality sign between them. So we have greater than or equal to 6. So I put them in here. Greater than or equal to, let me back up on this one a little bit. I put it in the middle, greater than or equal to. As we see that this inequality point me to use the letter OR instead of N. So I will go ahead and do that, connect to inequality by the letter OR. Okay. Then we will, so OR and N already be identified, then I just need to solve each inequality. And with the letter OR, we will take all possible solutions as we write on the side. What does that mean? Let's go into solve the problem. Toward the final answer, you will see what does that mean. So multiply by 5 on both sides. This will be cancelled out with that 5, or divide out. Will left me with 3 minus x greater than or equal to 30. Then we isolate the x, subtract 3 on both sides. So it will give me negative x greater than or equal to 27. Then we keep going and get rid of the negative by divide by negative 1 on both sides. That will give me x less than or equal to negative 27. As we practiced a lot of time before, when we divide by a negative number, we have to flip the inequality sign. And on this side, we do exactly the same. Multiply both sides by the LCD, which is 5. So 5 divided by 5 give me 1. And 1 times 3 minus x is still 3 minus x. Less than or equal to negative 6 times 5 is negative 30. Then we isolate the x, move 3 over. We have negative x less than or equal to negative 33. And divide by negative 1 on both sides. So we divide by a negative number, so we're going to flip the inequality sign to the opposite one. We have x greater than or equal to positive 33. Now let's put both of them in the number line and then see what my final answer would be. Negative 27 here and 33 here. I just make the parenthesis right here was not right. So 33 here. I'm gonna put the tail for the inequality sign. So at negative 27, that will point me to go to the right side, and with the equal sign, I will use the bracket. Then my next step is put the tail for 33. That will point me to the right side as well. And with the equal to, so we will use the bracket to connect them. Now let's put them both in the number line and see what is. Now let's put them both in the number line and then see what my final answer should be. So we have negative infinity, positive infinity, marked 2 points. One stands for negative 27, the other one stands for 33. What I'm going to do next is put the tail for the inequality sign. That point may go to the left. With the equal sign, I will use the bracket. Then on the second one, we will put the tail for the inequality sign. That point may go to the right. And with the bracket, with the equal sign, I will use the bracket. So as we see that the OR problem, we look with the OR letter, we take all possible solutions. So I'm going to take all what we have here. So we start from negative infinity all the way to negative 27. And bracket union to connect the second part, we have positive 33 go all the way through positive infinity. And that is my answer for example 2. Now let's go over example 3. We have negative absolute value of 3x plus 5 minus 2 greater than or equal to 1. So first of all, we need to isolate the absolute value. So add 2 on both sides, which will give me negative absolute value of 3x plus 5 greater than or equal to greater than or equal to 3. Then we divide both sides by negative 1. Divide both sides by negative 1. So when you divide by a negative 1, when you divide by a negative number, we have to flip the inequality sign to the opposite one. So we will have the following: 3x plus 5 less than or equal to negative 3. Now let's say if we keep going solving this one, we will have two inequalities. The first one is 3x plus 5 less than or equal to negative 3, and the second one is 3x plus 5 greater than or equal to positive 3. Okay, now with letters should we fill in the gap. So we apply the same concept, A and O, put the inequality between them, put this one in the middle. So that point me to use letter N to connect two inequalities. So we have N, then we solve each inequality. Minus 5 on both sides, we have 3x less than negative 8, and divide both sides by 3. We will have x less than equal to negative 8/3. Now on the right side, subtract 5 on both sides. We have 3x greater than or equal to negative 2, and divide by 3 on both sides. So we have x greater than or equal to negative 2/3. So now we put both of them in the inequality in the real number. So negative infinity, positive infinity. We have negative 8/3 and negative 2/3. So negative 8/3 will be a smaller number, and then negative 2/3. We see at negative 8/3, the point may go to the left. So we're gonna go to the left with the bracket. And at negative 2/3, that point may go to the right. So we go to the right with the equal sign. So another bracket. Since the problem we're dealing with is n problem, we're looking for where they overlap. And there's no overlap here. So the answer would be no solution. And we actually can see the answer in this step. See the absolute value of absolute value of 3x plus 5 less than or equal to negative 3. We know that absolute value always give me a positive number, and there's no way it's less than or equal to a negative number. positive cannot less than a negative number. So which means we can say no solutions in the step. No solution right here. But if you understand the concept, solving the absolute value inequality, and you know how to use and an or, you still get the final answer correctly, like we have here. Subject part. Now is your turn to work on the problem to prove yourself that did you understand the concept solving the absolute value inequality or not. So go ahead, practice on those four. If you get stuck, go back to the example. Make sure you understand the concept. So you have 5 seconds to pause the video. After that, we will discuss about those problems. So I believe you have your answer already. So my answer for problem 1 is -1 and 4, -1 to 4. And the answer for number 2 is no solution. The answer for number 3 is with the negative infinitive to positive infinitive. And the answer for number 4 is a point is from 5 to 5. This is a point. So I believe it's quite a surprise for you because the answer is a little bit different than what we have in the example, but it's good to see the new idea. If you understand or and you understand what is overlap and what is take all possible solution, I believe you have exactly those answers. So let's go over each of them together. On problem 1, we have absolute value of 2x minus 3 less than equal to 5. So absolute value already by itself. So my job right now is just break them down into inequality. So we have 2x minus 3 less than equal to 5. The other inequality is 2x minus 5 greater than equal to -5. So right now we need to find out what letter should we use to connect two inequality. So we have as we discussed before, if I put a and or between them, the inequality will point me what to use. So this one point me to use the n letter to connect them. Now we will solve each inequality. So add 3 on both sides. We will have 2x less than equal to 8. And divide both sides by 2. We have x less than equal to 4. That's the answer for my first inequality. Now the second one, we do the same thing. Isolate the x, so plus 3 on both sides. We have 2x greater than equal to -2. Then we divide both sides by 2. So that will give me x greater than equal to -1. Now we put both of them in the inequality number line. So negative infinity, positive infinity, mark 2 point, -1, and then 4. So put the tail for the inequality sign at 4. That point we go to the left. With the equal sign there, we will use the bracket and put the inequality sign. Put the inequality sign at -1. That point we go to the right, and with the equal sign, that will be another bracket. So as we see that n is the overlap part, so I will shading this part. We see that they overlap from -1 to 4. Now on problem 2, absolute value of 16x plus 6 close absolute value plus 2 less than 2. So we need to isolate the absolute value by subtract 2 on both sides. So we have 16x plus 6 less than 0. Okay, then we will have the first inequality is 16x plus 6 less than to 0, or and. In this case, it would be and. 16x plus 6 greater than -0. Then we will solve each inequality. So then we will solve each inequality. First of all, we need to get rid of fractions. So multiply everything by 6. So we have 6 and 6. 6 divided by 6 is 1 time. 1x times 1x is 1x, or basically just x. 6 times 6 is positive 36, less than 0 times 6 is 0. Then we subtract 36 on both, negative 36 on both sides, or subtract 36 on both sides. We have x less than negative 36. We do the same for the second inequality, so multiply by 6 on both sides. So 6 go to 6 one time, we will have x plus 36 greater than, I forgot to discuss about negative 0. 0 is the neutral number, is we don't have positive or negative 0. 0 in the middle of the number line. So basically negative 0 is still a big 0. And 0 times 6 will give me 0. Then we do next is subtract 36 on both sides. So we have x greater than negative 36. Okay, now let's put down the number line and then see what the answer looks like. I'm running out of space. Let's say I put it down up here. So negative infinity, positive infinity. So we just have only one solution, negative 36. I put the tail for the first inequality. That point may go to the left. So we have the arrowhead go to the left. Without the equal sign, that will be a parenthesis, which means it's not includes negative 36. So on the right side, I put the tail. That point may go to the right. Without the equal sign, I will use the parenthesis, so which also means not includes the negative 36. Right now we're dealing with the end letter, so which means we're looking for the overlap. Look on the graph, we see that there's no overlap. Even right here at the point negative 36, we have two parentheses, which means it not includes the negative 36. So that's why the answer is no solution, because we don't have any overlap part. So on problem 2, we can see is no solution from the beginning. From the time we have the absolute value less than to 0. So we know that absolute value always give you positive number, and positive less than 0, it doesn't make sense. So that's why it's no solution for number 2. Now let's go over number 3. We have absolute value of 7x plus 2 greater than negative 8. So we know the concept. We're going to break down at 2 equations. 7x plus 2 greater than negative 8. The second one is 7x plus 2 less than positive 8. We flip the inequality and change the sign on the right side. Change the sign of the number on the right side. Now which letters should we use to connect them together? So we have A and O and an OR. So put the inequality sign between them. That will point me use the letter OR to connect to inequality. So we're gonna solve each of them. Subtract 2 on both sides. So we have 7x greater than negative 10. And then we divide by 7 on both sides. So we have x greater than negative 10 over 7. On the right side, we subtract 2 on both sides. We have 7x less than to 6. Then we divide by 7 on both sides. So we have x less than 6 over 7. Now we put both of them in the inequalities number line. Negative 10 over 7 and then 6 over 7. We put the tail, that point may go to the right, and with the parenthesis, and put the tail for 7, 6. That will point me go to the left. Okay. since we work with the or letter, which means we take all possible solutions. So look at the graph, you see that the right side, I missed a parenthesis here, the right side and the left side has been covered. They even overlap to each other, which means every single number has been covered. So the answer would be from negative infinitive to positive infinitive, all real number. On number 3, we have absolute value. As we know that it's always give you a positive number, and positive number absolutely greater than -8. That is the true statement. That's why we have all real number as the answer. Now let's work on number 4. So we have absolute value of x minus 5 divided by 10 less than or equal to 0. So our job is break down at two inequality. So x minus 5 less than 10, x minus 5 divided by 10 less than or equal to 0, and x minus 5 less divided by 10 greater than or equal to -0. And we talked about this before, we don't have -0, so basically it's just 0. Then we multiply both sides by 10 to get rid of the denominator. So 10 divided by 10 is 1 time x minus 5 will give me x minus 5 less than or equal to 0 times 10 is 0. Then we add 5 on both sides. So x less than or equal to positive 5. We do the same for the other one. So multiply by 10 on both sides. We will have this divide out. We will have x minus 5 greater than or equal to 0. And we isolate the x at 5 on both sides. So x greater than or equal to 5. Now we're going to do is put them in the our real number line, negative infinitive, positive infinitive. We mark a point, that's my 5. Put the tail for the inequality, that point may go to the left with the bracket. And let's see, not that one. Okay, then I put the tail for this inequality sign, that point may go to the right, and with another bracket. So brackets stand for include number 5. So right now we're working on the end problem, which means we're looking for where they overlap. So as we see that the bracket, which means includes 5, both side left and right side, they includes number 5, which means they overlap at this point. That's why my answer is from 5 to 5. 5, 5 is the answer is one solution is 5. And we can see quite clear on this problem, since the absolute value always give you a positive number, and positive number cannot less than 0. So the only possible case can happen is this positive number equal to 0, which basically you can solve the problem as x minus 5 divided by 10 equal to 0, because we know this absolute value always give you positive number with not less than 0. The only case is can happen is equal to 0. And if you solve this problem, you will see that we will have x equal to 5 is exactly like the answer we have here. So last part, extra practice. I have 9 problems for you to work on. Go ahead, practice on them. You have 5 seconds to pause the video. Then I will show you the answer after that. Alright, good luck everyone. Alright, here the answer. Thanks everyone. I hope that we have a correct answer and we grasp the concept how to solve the absolute equation and absolute inequality. So thanks for watching and see you on next video.